Everybody, and welcome back to Automate Live. My name is Winn Hardin. I'm the co-host of Manufacturing Matters podcast, and I'm thrilled to be here today with Moti Shtrobach. How you doing today, Moti?
Very good, thank you.
Beautiful. Moti is the Vice President of Cross-Industry Business Development at Valens Semiconductor. So how's the trip been from Israel, Moti?
Long way, but weather is great, so
Weather's great.
we can enjoy the weather
The
here.
equipment showed up, no missing pallets.
Everything is okay.
Fantastic. So for those who may not know Valens Semiconductor, Moti, tell us a little bit about what y'all do.
So Valens is a semiconductor company, and we provide the chipset for high-performance connectivity.
Okay.
There are a lot of industries that need this type of high-performance connectivity, and we are working with leading vendors in the industry.
Mm-hmm.
We have companies like Logitech, Epson, Samsung that are using our technology. We have companies like in the automotive, companies like Mercedes, Daimler is using our technology inside the car for high-speed connectivity.
Right.
So if you are lucky and you have a Mercedes car, then it means that you have our technology inside. You enjoy it. Other companies are like Siemens, Beckhoff, B&R, that they use our technology for human-machine interface extension, having the ability to control using interactive display from a long distance.
Okay.
And we're very popular for most of the companies that we have today. They use our technology chipset that is doing HDMI, USB controls, and that's why it's very good for human-machine interface and digital signage.
Okay. So wherever high bandwidth, high reliability, data connections need to be, that's where Valens is focused in at.
Exactly. That's the place where we do the best.
Very cool. And I know we're going to get a lot deeper into some of those applications you talked about, automotive and others, and about why you're here at Automate. But this is your first time coming to Automate, if I'm correct. Is that right?
Yeah, that's right. So we are bringing it's the first time, as you said, and we are bringing a new technology that we believe that could change the way cameras are connected in the industrial world, in applications like robotic arms, AMR robots, the machine vision. We have a new chipset that is based on a standard, the first in the market that comply with a standard called the MIPI A-PHY.
Okay. And that's A-PHY, right?
A-PHY, yeah, exactly. Gotcha. And it's this standard was, as I said, defined by MIPI Alliance. The target market was for the automotive, because the number of cameras that you see in the cars are increasing. I think that even today, you will see that the number of cameras that are being sold for cars are probably more than 100 million. Think about the different applications like driving assistance, autonomous driving, surround view system, driver, passenger monitoring. There are a lot of cameras and this market is actually growing every day.
Yeah.
And so MIPI Alliance identify,
parking assist,
exactly.
Controls, rear view cameras, even not even the most advanced cameras, but we're just seeing that volume grow up. You said 100 million. Is that about? Was that the estimate?
It's probably even more than that. I think that what I've seen is that in 2020 it was like 80 million, and I assume in the last 5 years it's much more than that.
Okay.
So MIPI Alliance identified that there is a need for an ecosystem and standard. They defined a standard to extend CSI, the camera serial interface. And obviously, when you define a standard for the automotive, you need to make it optimized from almost any point of view.
Right.
It should be very reliable, very high in performance, and also very low in cost.
Right.
And why do I tell you that? Because we believe that this technology that was was developed for the automotive, we believe that the industrial market, which especially today that you see more and more applications like embedded and AI,
Yeah.
the industrial vision market can enjoy all the benefit and the effort that was spent to make A-PHY good for the automotive and enjoy low cost, best performance, and improved cabling solutions for the machine vision and the industrial vision in general.
So when I first heard about MIPI, I think of the cell phone market.
Yeah.
Right? Is that where the standard was initially developed?
So the MIPI Alliance defines the CSI interface, which is the sensor connectivity. It's connectivity between the sensor and the application processor, like in a mobile phone.
Right.
And the A-PHY is the same interface with actually extending this interface over a long cable. That's what it does.
Yeah. So the PHY does reply to a physical layer then, saying that you've got a different physical layer a little bit.
Yes, that's right.
Okay.
Yeah.
And it's interesting you talk about the growth of MIPI in industrial applications, because we see this is initially cell phone communication standard that was initially developed and chipsets around that. But then as we go into automotive, these are safety critical systems.
Yes.
Right? I mean, facial recognition on my cell phone may not actually let someone go into the hospital. But if you've got a backup camera or autonomous driving vehicle, and when those cameras go down, then we have the chance for harm or something worse.
Yeah.
So is that part of why you see this making the transition into industrial applications?
Yeah, well, again, it's the same problems that you have in a car. You need let's take as an example, as you said, the autonomous driving.
Yeah.
The link should be the most reliable link, right? This is the technology that later the car will take decision what to do, right? If to press on the brakes or anything else.
Right.
And the industrial market, you have the same challenges. You don't want to have a production line stop because of failure of a cable, right?
Right.
So,
plus,
in a way,
put employees at risk too, possibly, quite
Yeah.
possibly. If there's safety considerations, things of that nature.
Yes, that's right.
Right.
And it also brings additional advantages, improved cabling. We have features like advanced diagnostics that you have. You can actually know when is the point that you need to maintain the cable. I've heard
Like a maintenance element. So is it actually providing the health? Some information on the health of the cable itself.
Yeah, exactly. I've been here in one of the booth here for that. I see that the size of the cameras and the thickness of the cable and they told me that the challenge is that even if you can replace the cable might be very cheap, but the maintenance, the cost for the maintenance could be very expensive. And the fact that the machine stops, that's the thing that costs the most. Okay. The fact that you cannot...
the downtime,
stops.
The lost productivity becomes the greatest loss to the company, right? It's not the cable itself necessarily, or even running a new cable or replacing a cable, but that lost productivity can result in millions of dollars per minute, depending on what industry you're in. So I could see that being a critical component. I'm just curious, if you don't mind me asking a question, is that done through error detection in terms of like forward error code correction, or is it actually measuring electrical responses, conductivity resistance?
So the standard itself actually defines every chip that supports A-PHY.
Okay.
The standard defines 6 levels of performance that you can get from the link. And also the standard defines ways to overcome problems. For example, A-PHY supports retransmission of data. So even if you do not see one single error over the link, it doesn't mean that there are no errors. And the way A-PHY implemented that is that if there is an error, the packet that will be retransmitted with higher immunity to noise, which makes the link very, very robust. And this information that you get from the chip, it's another indication that you can use to know what's the point that you need to replace the cables. If you see, for example, that the number of error goes up every day, it means that the cable is going to die, and that's the point that you need to set maintenance for the cable.
So it's the system itself is partially defined and designed, right, to be EMI resistant a little bit too. I mean, if we're not just talking about cable conductions, but it's able to adapt to changing environmental conditions.
Exactly, yeah.
That's fantastic. That's really cool. So do you have products here today that you're showing that are using the...
Yes, we actually have very nice demos that show all the advantages of A-PHY. We show here very challenging links that the chip should overcome. Cables like unshielded twisted pair, which is, you cannot see this type of solutions. We extend 4 gigabit per second over unshielded twisted pair cables.
No kidding.
And this could be very beneficial for the industrial market. Think about the flexibility of the cable.
Right.
Avoiding aging of coax cables, the ability to terminate the cable in the field and still have a very high performance connectivity. We show demos of micro coax, very, very thin cables that we extend both power and 8 gigabit per second over the link.
18 gigabit per second.
Long cables, we can do up to 30 meters, 8 gigabit per second as well. So the chip is very robust, very resilient to EMC.
Okay. So if we go over to Valens Semiconductor booth, we'll see machine vision applications going. We've got cameras hooked up right now where we're sending image data.
So we show that we have some demos that show the advantages of the technology. We have an excellent product from D3 Embedded that they integrated A-PHY to both the camera side and also an NVIDIA platform that integrates 8 ports of A-PHY. So it's actually an embedded system ready in the market, supports A-PHY, and with the ability to connect up to A-PHY cameras, each one of them up to 8 gigabit per second.
Okay. Now, I know a lot of other dedicated, very high bandwidth, high reliability standards or communication protocols, like in machine vision, camera link is something. When that first came out, the chipsets were expensive. You needed a frame grabber, you needed both end, chipsets at both ends to be able to handle it, right?
Yeah.
Is it the same conditions for MIPI or A-PHY, or does that autonomous vehicle connection, that cell phone connection give us?
So I think that there are a couple of things that are different. First, the fact that it's a chip that the target is for automotive means that the price point is better than solutions that are fully dedicated for the industrial vision. This is one point.
Right.
Second, the technology that you're talking about, for example, camera link, Vision, CoaXPress, they all need an FPGA in order to implement the protocol, which makes the camera much more complex, bigger, higher power.
Yeah.
And A-PHY, if you will come to our booth and see the camera, you can see that camera can be as small as like less than 1 inch of size, and they're also very low in power.
So, Moti, I know we're getting close to the end of our time, but is there anything else that you're showing over at the booth other than the MIPI A-PHY?
Yes, so we actually have a new product, an extender for USB Vision.
USB3 Vision.
USB3 Vision.
Yes, sir.
It's an extender, and it is based on a new chipset that we have for the professional audio-video market and the IT market. This chip can extend full USB 3, USB 2 controls, power over category cable up to 100 meters.
100 meters.
And
that's over copper?
Yeah, category cable.
Okay.
No, category. Yeah.
Beautiful.
Copper.
Gotcha.
And
normally you have to go to fiber to get that kind of length. In most cases.
Yeah, that's right. So we
that's with a single repeater?
Yeah.
No. Oh, wow. Wow.
And we have a lot of customers that are already releasing products based on that to the market, USB 3 extenders. So if you find USB extenders in the market, probably they are based on HDBaseT Valens technology.
Awesome.
And we also took it one step further in the case of the industrial, and we made an industrial extender optimized for USB 3 Vision. And this extender can extend USB 3, USB 2, very accurate trigger, IOs from one side to the other, and serial interface as well as power, not only to the camera itself, the USB camera itself, but also to accessories around it. So, for example, if you want to add an LED lighting next to the camera, you don't need to add more power wires to do that. So the advantage is that one cable, all wires, everything is going on one wire. It's a category cable, very cheap, long distance with ability to terminate in the field. And that's what we bring to the market. We have it in engineering samples for customer evaluations, and it's going to be released to the market later this year.
That's fantastic. Moti, thank you so much for joining us today on Automate Live. I know this won't be the last year that we'll see Valens Semiconductor back here in Automate, hopefully next year in Chicago, and then I think the year after in Vegas, so don't miss that, that's for sure.
Thank you very much.
My pleasure.